Okay, in this question, we have a triangle S, Q, and R. Okay, so from previous calculations, we have already obtained that the value for the angle QRS is 141.26. So the calculation that's going to be done is assuming that the value obtained in QRS is accurate. Okay, so when we come across this kind of triangle, we reach a situation where we have an ambiguous case. So an ambiguous case meaning there is more than one way to draw the triangle. So this could happen for several reasons, okay, where you have a particular line which could be in two different positions, right? So in this question, they ask us to draw a new triangle S prime, Q prime, and R prime, and it is supposed to have a different shape from the one that is given here, right? And they do give a condition. So the condition given here is the S prime R prime line must be equal to SR. So that means the line in the new triangle must be in equal length to SR. So it must be 6 cm. And then we see the next point, which is S prime Q prime is equal to SQ. So that means the value of SQ in the new triangle also has to be the same, right? And they also say that SQR has to be the same. So that means this angle here, even though at the moment we don't know what is this particular angle, we don't know, right? So that has to be the same. So so this is an acute angle, right? Because this is definitely less than 90 degree based on what we can see. It is less than 90 degree. So in this case, all right, the line that can be moved, right, would be SR. SR is a potential line that could be moved, right? So there's a few ways that you can move it, right? So it could be, right, it could be that the line uh, becomes like this. So let's assume, right, let me get that line. I'm gonna get a line. Hopefully this is going to give me a red color line. Oh no, that's too big. Let's make it a little bit small and change the color to red color so that it's easier for us to see. So I'm just going to change this a bit. Okay, so I'm just adjusting the line so that we can see a bit more clearly. Okay, so there's a few ways that we can do this. So um, I'm going to adjust with SR, right? So I'm going to adjust the line SR in such a way that it remains 6 cm. So it could mean, right, that I could adjust the line SR. So let's say if I move SR to somewhere along here, and let's assume that it is going to be SR equal to 6 cm. All right. So the condition is I have to meet the condition given in the triangle, which is SR has to be 6. All right. So let's say if I move it to be over here, and it remains to be 6 cm. But now I come with a new problem, which is my SQ is no longer the same as in the old triangle. So let's say if SQ in the old triangle was 14.18, 14.18. If I move SR in this particular position, then the value of SQ changes. Hence, it will be inaccurate. So that means this is not the way to change the position of SR. So that means I have to think of a new way to change the position of SR. So I'm going to return it back to its original position. Okay, so now what if I move SR in another position? So that means instead of that way, perhaps I can move it in this way then. So maybe this is another alternative that I could have. So and let's assume that the new position gives me a 6 cm. So let's lock it down there. So let's say that is 6 cm. And let me get my brush. So let's say that is 6 cm. Let's say that this is 6 cm now, right? So there's a new line that we're going to add, which is this particular line. So I'm just going to extend this, and so this will form the new triangle, right? So the new triangle is here. This is our new triangle. So this will be our uh, new triangle. So this is Q prime, and this will be our S prime, and this will be our R prime. So have we met the condition given in the question? All right, so let's check. So the first condition is SR prime has to be equal to the original line. That means in terms of length, yeah, we could maintain that. All right. And the next one is SQ has to be the same. Yes, we could maintain that. Right. So that means the only difference now is QR. So you could do further calculation to find that value. Okay. And the next one is you have to know um, okay, SQR has to be the same. So in our new triangle also, SQR has remained the same. It has not changed. All right, the angle Q remains the same. Okay, so in the next question, they ask us to state the value of SRQ. All right, so with any ambiguous triangle, all right, so let's say if one of the triangle given is 141.26, then the other angle, right, the angle over here, all right, to find that angle, what we would do, it would be 180 minus 141.26. So if you were to ask me why do we do that? So there are a few reasons why we can do that. So the first reason is because if you were to do this using the sine rule, so um, when you do this using the sine rule, right, um, you would get the angle a positive value, right? Sine r would be a positive value. So when you do shift sine, for sine to be positive, it is in two quadrants. So the first quadrant, which is the acute angle, we'll just take it as it is, and the other angle, to find that we would have to take 180 minus the first angle. So these two angles, when you add them up together, you will actually get 180. All right, so that's one reason. If you were to ask for another reason, then we could also look at it at this way. All right, so since now we have made this triangle, right, but in one sense, you also still see the isosceles triangle. So let's say I'm just going to shape the isosceles triangle here. I'm just going to make it a little bit more thinner so that it doesn't block. So this is our isosceles triangle, right? So you see the blue color line that I drew, right? So that is our isosceles triangle. So that means whatever angle that is here will be the same as the angle here. And we can find the angle here by taking 180 minus 141.26. And so since this is an isosceles triangle, the angle here will be equal to the angle here. Okay, so the value for that angle, right, um, should be 180 minus 141.26. So it should be 38.74.